Hello, good morning. This is Claire, and we're looking at lines with one intercept. So that means they're just cutting one axis, but not the other axis. So that generally means that they can be horizontal or vertical or go through the origin. So these have little patterns, and it's good to be aware of these. Let's look at a horizontal line, or a line which is parallel to the x-axis. So it cuts the y-axis in exactly one place. So there is a horizontal line, and it actually cuts right through +3 on the y-axis. So this line here is known as y equals 3, and I'm going to show you why. So if you look at any of these points here, this horizontal line y equals 3, if you substitute x equals -2 into here, the coordinate on that line is -2, +3. The same thing when you substitute -1 into that line, you find you have this point which is -1, 3, 0, 3, 1, 3, and 2, 3. So you can see that the y coordinate is always 3. When the y coordinate is always 3, you call that line for that rule y is a constant, so y is equal to 3. For a vertical line, let's choose negative. Maybe we'll choose -4 here. So a vertical line cuts the x-axis in one spot, but does not cut the y-axis at all. So this line here, we're going to find the substitute the values in to find all the coordinates. So let's find some coordinates on this line. Now I haven't filled in the values for x here for a special reason. So when y is 0, what is x? X is -4. So when y is 0, x is -4. What about when y is -1? When y is -1, what is x? It's still -4. When y is -2, down here, x is still -4. When y is +1, x is still -4. And when y is +2, x is still -4. So you can see here, the x is a constant, it's always -4. So we call the rule for this line x equals -4. So here you have x equals -4. And you can see that the x coordinate always the same. So some other lines that are important to find are this very important line, y equals x. So that means the x and y coordinates are equal. So the y coordinate is going to be equal to the x coordinate. So in each case, they are exactly the same. So we'll plot these points. When x is -2, y is -2. When x is -1, y is -1. When x is 0, y is 0, so it goes through the origin. When x is 1, y is 1. When x is 2, y is 2. So what you get here, it's meant to be up there, you get a diagonal line, and you can plot these, put a line through those points we've just plotted, and that line there is y equals x, and the coordinates are exactly the same. So what happens when y equals -x? So that means you're going to multiply the x values by -1 to calculate the y values. So if x is -2, -2 times -1 is +2, because a negative times a negative is a positive. When x is -1, multiply it by -1 will be +1. When x is 0, -1 times 0 is 0, so it goes through the origin. That's the origin pattern. When x is +1, multiply that by -1, it'll be -1. When x is -2, multiply it by -1, it'll be -2. So if we plot these points on the axis, when x is -2, y is +2 up here. When x is -1, y is +1, and it goes through the origin. When x is 1, +1, y is -1. When x is +2, y is -2. So we've plotted those points, and you can see they are on a 45-degree angle going through the origin, and that line there is y equals -x. So there's some important lines. Just having a look at the horizontal line here. This, if you imagine you were riding a bike along this kind of line, it would be very easy because there is no gradient. It's just a very easy bike ride. There's no slope. And when there is no slope, we say that the gradient is 0. If you looked at the rise over run, so if you went across one, so that's the rise is 0 and the run is 1. So on this line here, the horizontal line, the rise over run, when you go across 1 unit, the rise is 0. So 0 divided by 1 equals 0. Because you can divide 0 by a number, and the answer is 0. So a horizontal axis has a 0 gradient. And just imagine, it's an easy bike ride. Imagine if you were trying to climb this cliff, of a vertical cliff. It would be extremely steep. In fact, it's infinitely steep. So if you imagine here, for example, you're getting the rise over run, the run is actually 0 and the rise is infinite. So the rise is infinite over a 0 run. And you cannot divide by 0 in the real number system, so it's not determinable. So you cannot determine this. So it's not determined or not defined. So that does not have a gradient. The gradient is so steep and you cannot divide by 0. The gradients of these lines here, for example, let's look at y equals x. So every time you go across one, you go up one. So the rise is 1 and the run is 1, and they're both positive. It's an uphill line. So the gradient, the rise over run, is 1 divided by 1, which is 1. The gradient of this line is every time I go across 1, I go down 1. So the gradient is -1. So the rise over run of y equals -x is the rise is -1 and the run is +1, so the gradient is -1. So this is a negative gradient line and this is a positive gradient line. Uphill is positive and downhill is negative. Thank you for listening. The next thing I would like to challenge you with is graphing, finding the coordinates and graphing the lines of something like y equals 4x, so 4 times x, or y equals -2x. Both of these lines go through the origin and they have different gradients. So I'd like you to graph these two lines and write a t-table. Thank you for your attention. Bye for now.